Hey everyone, in this video we will be talking about some of the key concepts of distributed system design. So some of the basic terms which we use in day-to-day lives and some people don't even know like what does that mean, right? So in this video I'll be covering those basic terms before like jumping into the real implementation of any bigger system, right? So first thing is before designing any system, like what you have to do is take a step back and think about what all different components are involved in the system, right? So once you figure out what all components are involved in the system, then think about how all these components and services will interact with each other, right? What all information or data they have to exchange and how basically the interaction will work into it, right? So once you know these things, once you figure out the components and the component interactions, right, then is when just dig deeper into each component design and evaluate what all the trade-offs of the different implementations before finalizing into anything, right? Because the choices which you will make today, right, in designing any system, that will definitely impact you in the longer run. It can, a better system design can save your valuable resources and each and everybody's time, right? Of course. So let's see the basic key concepts uh, involved in any system design. So first is scalability, how scalable your system is and how reliable your system is and how your system, whether your system is available or not, and how efficient your system is, and is it even easy to maintain, right? So now let's dig deeper into each and every these terms, right? So first let's talk about scalability. So scalability is like how your system will scale, right, when your business grows, right? So simple example is, for example, today you have a website which is getting 10 requests in a minute, right? And let's say in future your load on the website increases, you get 1,000 requests per minute, right? And how your system will handle all those things. So scalability is not even like it's not really traffic. Your system may have to scale because of n reasons, like because of um, increased data load, right, or increase the number of transactions or anything, right? So you can scale your system in two ways. One is the horizontal scaling, and the second one is vertical scaling. So horizontal scaling is, so today you have a web server, right? And now you can add more servers because your traffic on the system is increased. Think it like, for example, if it's a website, right? Let's say it's Azure web app, right? So to handle the increased load, you can increase the number of servers, right? For example, this is of 4 GB RAM, and so you can add just one more server with the 4 GB RAM, and like that, based on the business need, you can scale your system. And you don't really have to do this. It depends what kind of product you like you are using. For example, in Azure web app you can set the rules, right? So if your requests are taking more than certain seconds or minutes, you can add more servers, right? Or if uh, you are getting more traffic, right, you can have those, you can configure those kind of rules. And if your system is taking one server, particular server is taking 70% CPU, right, you can add rules, right? If this server is taking more than 70% of CPU, then plus one, add one more server, right? So these things you can automate and manage, like for example, this kind of model you can follow on MongoDB, Cassandra, and Azure Web Apps, right? Another one is the vertical scaling. So where you don't really add new servers, but you add a bigger system. Like for example, today your system is 4 GB RAM. So you will increase you will have one server. You will replace the server with a new server which will have more RAM, like 32 GB, right? And this one is 64 GB and more computation resources and things like that. And this is called vertical scaling. So you might have done this in the past because for MySQL, like that's a probably right example for this one. So next is the reliability. So how reliable your system is. So let me give you an example. So I think I personally think reliability is the like very important thing. Um, for example, you have an e-commerce website, right? And user selected certain items, added them into the cart, and for example, if that node fails, right? So when you add something in the cart, your request goes to one server, right? And what happens if that server fails, right? Or for example, this cart data, what each user have added certain items in his cart, right? And all those data is, let's say, stored into one node, right? And if that node dies or fails, right? So what happens? There will be data loss, right? And certain next day user will see that there is nothing in the shopping cart, right? Because your node which were carrying the user data failed, right? That's misleading, right? That should never happen. So what you can do is to make a system more reliable, you can replicate the user's data. So even if your one node fails, so your system should be able to um, get the data, get the user data from another node, right? Basically, it's called as data replication. You you replicate the exact same data on multiple nodes, if just to avoid a single point of failure, right? So that users are not impacted and there should not be any data loss. And of course, reliability or when you are replicating data, it comes with additional cost, and that's, I think, every reliable system have to pay extra cost, right, for it to be reliable. And the next thing is availability. So your system should be available, up and running always, right? And this is very important line. If your system is reliable, it is available. However, if it is available, it's not necessarily reliable. So, for example, you have a website which is 100% reliable, never goes down, but doesn't mean that it's necessarily reliable, right? Let me give you an example. So, you developed something which people are using from so many years and everybody is happy about it, but that have uh, some security vulnerabilities, right? And people have not done enough security testing and the system have loopholes, right? And so now after years, so you have to bring the whole system down because that's not reliable enough, right? And that have certain loopholes which needs to be fixed. So yeah, that was one simple example that it's pretty simple that your system is available, but available doesn't necessarily mean that it's reliable. And the next thing is efficiency. So how efficiency is, of course, like how efficient your system is. Like for example, if your system is doing one simple task, it's searching a term, right? How efficient it is to do its job. Like how much time it takes to uh, return the results, right? Basically, the latency and throughput of the system. And last but not the least is maintainability, right? So think about um, like for example, if you get some bugs in the system, right? How easy are those to fix? Like it should be in maintainable state. So um, that's pretty much that are the some key basic terms, but in the next upcoming sections, we'll be talking about the load balancing, data partition, and a couple of more things. But that's enough for this video. Thank you so much for watching.